If you're used to working with circuits with LEDs, you might know that there's one important rule. Never forget your current limiting resistor. If you do, or use a resistor that's too small, that's a quick way to burn out your LED, as you can see here if I connect this LED directly to the battery pack. If the voltage across the LED is too high, you can even cause it to explode. You might be surprised then if you ever build paper circuits, which commonly use copper tape in place of a breadboard and lithium coin cell batteries in place of AA or AAA batteries. Both of these batteries supply the same 3 volts, however you'll notice that this circuit doesn't have a current limiting resistor, and the LED is remaining at full brightness instead of burning out. In case you don't believe me, we can confirm this with a multimeter. Here we have a fresh CR2032 lithium coin cell battery. We're going to hook our multimeter up, and we see that we get almost exactly 3 volts. Here we have 2 fresh AA batteries. We're going to connect those end to end so they're in series, and we'll see that when the batteries are fresh, we get just over 3 volts. Why then will this LED burn out if I connect it directly to these batteries, but this one does not, even though it's already directly connected to this battery? The answer is related to the battery's internal resistance. All batteries have some internal resistance. For AA batteries, that resistance is pretty small, less than an ohm per battery. For coin cell batteries, that resistance is much larger, around 10 ohms for this CR2032. We can demonstrate this by quickly measuring the short circuit current of each battery. Now note that normally you don't want to short circuit a battery since this can cause dangerous overheating. I'm just going to do this quickly for demonstration purposes. Also note that I have switched my multimeter over to the 10 amp current measurement port and setting so I don't blow the fuse on the 200 milliamp port. So I'm going to take my battery here, and very quickly we see that if I short circuit it, I get a current of around 500 milliamps that rapidly starts dropping. So the battery is not designed to be short circuited and it can't supply that high of a current for that long. It starts to level off around 100 milliamps. However, if I take my 2 AA batteries here with that same 3 volts and short circuit them, I get a whopping 7 amps to start out. So there is a much lower internal resistance on these batteries, which allows them to provide much more current, even though they have the same voltage. And that is why it is critical to have an external resistor when you are powering LEDs with AA or AAA batteries, but they are not needed when you are building paper circuits with a coin cell battery. Most common LEDs are rated to handle about 20 milliamps of continuous current. They can handle a little more than that, but then that might decrease their lifespan. If you start getting too high, like close to 100 milliamps, that might burn them out instantaneously. So since these AA batteries can provide amps of current, they will rapidly burn this LED out if you connect it directly, whereas this coin cell battery can really only supply 100 milliamps even if you short it directly to itself. So to an external load, it's probably only going to deliver tens of milliamps, which is not enough to kill the LED even with no resistor. Now, if you would like to see instructions for building circuits using breadboards or paper, go ahead and visit the links in the description below this video. You can also check out www.sciencebuddies.org for thousands of other fun, hands-on science and engineering projects.